Using mathematics, the ancient Greeks provided more detailed information about our dominant celestial neighbors, the sun and moon.
Even back then, 2,000 years ago, they knew that the earth curves. And by looking at the shadows, they calculated the size of the earth to within about 10% accuracy. They actually calculated the distance from the earth to the moon and the rough dimensions of the distance from the earth to the sun. So in other words, the ancients were no fools.
The ancient Greeks also recognized two types of stars. Most were fixed and small and moved together. A few were larger and moved haphazardly, or so it seemed. These were planets, and predicting their motion became a centuries-long goal. With just their naked eyes to scan the skies, the Greeks saw only 5 planets, naming each after their gods. Today, we're more familiar with their Roman designations: Mercury, Venus, Mars, Saturn, Jupiter. Ancient astronomy assumed a concept of the universe proposed by 4th century BC Greek philosopher Aristotle, who imagined the Earth at the center of the universe, with the sun, moon, stars, and planets all revolving elegantly around it in perfect crystalline spheres.
Aristotle's universe was finite. It was a big sphere. Actually, it was like onion. It was an onion with many concentric spheres.
1st century astronomer Ptolemy improved on Aristotle by accurately tracing the paths of the planets, which didn't move haphazardly after all. Using complex circular motions called epicycles, Ptolemy could predict their prescribed paths and changing velocities. In other words, Ptolemy's system reliably predicted the future behavior of the planets, another step in man's journey to understand and control the universe.
The Ptolemaic system was extremely complex. It had all these planets going in loops, and it worked beautifully, but it was just wrong. The idea that you can predict something doesn't mean you understand the fundamental principles behind it.
Ptolemy's system did not accurately reveal the universe, but it didn't try.
He essentially showed that the positions of the planets could be calculated for any time past or future. It was a tour de force of mathematical understanding. Interestingly, the astronomy seemed to stand still for centuries after that.
In fact, after the collapse of Rome in 476 AD, astronomy actually lost ground.
Europe fragmented into smaller powers, and a lot of the wisdom of the Greeks was lost.
1,000 years later, a new theory would confront accepted beliefs about how the heavens worked and would move mankind one step closer to a theory of the Big Bang.